a couple different ways, again, that you can approach this problem. I'm sure there's several different methods. As long as you communicate how you did it, you're going to be good to go. We know that density is mass per unit volume, right? And they have given us a mass here already. We know that the package of aluminum foil weighs 12 ounces. The problem is that our density has been given in grams per cubic centimeter. Can we change from ounces to grams though? Yes, we have a conversion here. So let's do that first. Let's just take care of the mass part of it. We have 12.0 ounces, that's an OZ there, times, now we want to get rid of ounces and we want to change it to grams. 1 is the number that goes with the ounces and 28.4 is what goes with the grams. When I did that part of it, I got 340.8 grams. Now, I'm not going to worry about my sig figs until the very end. Most of the time, the AP curriculum tells you to wait until the very end to decide how many sig figs you have rather than doing it in between time here. So I've taken care of the mass part of this. The volume. Again, we have a piece of aluminum foil that has volume. It has a length, it has a width, and it has a height, which we really call the thickness of the foil. Length times width is what? Yeah, that's area. I'll give it a capital A here. Area is length times width. They've given me the area. The problem is that it's in square feet, and my density is going to be, well, it at least has metric units here of cubic centimeters. So we're going to start with 75.0 square feet, and we're going to change it, oop, don't lose my square there, we're going to change it to metric units. Now, the only metric unit that I have memorized is that 1 inch is 2.54 centimeters. All right, that's really the only, at least distance metric unit that I have memorized. I can get most of the other ones from there. Now, we're not dealing with inches though, we're dealing with feet. Can we get from feet to inches? Yeah, all right, I can get rid of feet and, uh-oh, big problems. This is square feet. I only know that 1 foot is 12 inches. What are we going to have to do to these values in order to get them to be squares? Yeah, you're going to have to square that and square the denominator also. That will cancel the square units or the square feet, and it will change it to square inches. Now, I don't care how you do it. If you just want to put that in your calculator as you do the problem, just make sure that you do eventually square the 12 also. All right, so it's eventually going to be 144, whether you write it in or not. We are out of square feet. We are into square inches. We want to get to centimeters. So here's my conversion. I want to get rid of inches. I want to change it to centimeters. I know that 1 inch is 2.54 centimeters. But once again, we don't want just inches and centimeters. You're going to have to square the conversion factors. You're going to have to square 2.54. You're going to have to square 1, which is just 1. But in order to get this out of square inches, you have to square the 2.54. Now, when I put all of this in my calculator, I got a really obnoxious number. I got 69,677.28. The units come out, though, to be square centimeters. very close to 70,000. But again, you want to wait until the bitter end here in order to get the correct number of sig figs. All right, now where were we? Oh yeah, okay. So now we have the mass. Let me change that. Let me put that in here. The mass was 340.8 grams when we converted it to grams. Now I have the area in square centimeters, and it is 69,677.28. That's square centimeters. I don't have the height yet. That's really what the problem was asking us to look for, the thickness or the height of the aluminum foil. I do know the density. They told me that it was 2.70 grams per cubic centimeter. Now here we are, all set up. We have the formula, we have everything but the height that we're looking for, and I'm just going to presto changeo here for you. All right, you would take the height over here and then take the reciprocal of 2.70 grams per cubic centimeter. The square centimeters are going to cancel out for you, so that the height eventually is going to equal 0.001798, 0.001798, and that's centimeters. All right. Now we have to look at a couple things here. First of all, sig figs. With the sig figs, we started here with 3 sig figs for the area, 3 sig figs for the ounces. We started with 3 sig figs for the density. And our conversion, again, remember with a conversion it's understood to be infinite number of sig figs. So even though there's only 1 sig fig showing there, because this is a conversion, we assume it to be an infinite number of sig figs. So I really want to round my answer to 3 sig figs. And when I do that, not significant, not significant, 1, 2, 3, we're going to round it to the 3 places here, 0.0018. And I need 3 sig figs, so I have to add a 0 there, and that's centimeters. All right. If you want to rewrite it in scientific notation, 1.80, again having your 3 sig figs, times 10 to the minus 3 centimeters, that's fine too. There's no real rule for when to change to scientific notation or not. I usually start to change to scientific notation after I have 2 or 3 zeros here in, as a placeholder. But there's no steadfast rule for when to change to scientific notation. To get this, there's one more thing. They wanted in millimeters. Let's change it to millimeters. Get rid of centimeters, change it to millimeters. We can probably do this in one step. Which one's bigger? Yeah, a centimeter's bigger. There's 10 millimeters in a centimeter. And moving your decimal point, again, 1 place to the left, this would come out, I'm sorry, yep. Well, you're dividing by 10. Oh, I've got it upside down. I knew there was something wrong there. There's the millimeters. Thank you for helping me out with that. And then this is centimeters in the denominator. You're multiplying by 10, and it should come out to be 0.0180 millimeters. All right. Okay, we're almost there. Let's go to the top of the next page.